Alrighty. Okay. There we go. Should probably fix that. Yeah. Alrighty. Let's change this. Alright, hello, everybody. Oh, we have people come to trickle in, certainly. I hope everybody is doing well this very fine day. So, hopefully, you're doing well. So, yeah. It's all good. Need this. I'm also gonna need this. I need the paint tool. Wait, I need this. Yeah. There we are. There we are. We got ourselves a winner chicken dinner. Very nice. I guess I haven't been bamboozled, Wade. How you doing, buddy? Welcome back again. I have been bamboozled. I ain't gonna lie. How you doing this afternoon / evening, my dude? There we go. Nothing changed. Hopefully things are okay with you, and hopefully you've been doing a little bit of the homework. So I've been bamboozled lots of times. Had a lot of fun this morning, actually. In all honesty, we had a ton of fun playing some marbles and whatnot. Never a bad thing. Haven't seen that pick before. Really pick. All right. How are we? Sure about that. Okay. All right, about 5 minutes to go here. Go ahead and. All right, 5 more minutes. We'll go ahead and get going right after that. Good stretch, could never. Oh, this doesn't. Alright. Obviously can't use that. Limited capabilities are limited. Hey, Susan, how you doing? Good evening to you. How are you been? Hopefully, you've been doing well. Hopefully things have been pretty chill the past couple days. Getting into a nice, hopefully easy lesson today. Just takes a little while to explain, but hopefully it won't be too bad. Hopefully take it nice and simple, and then my goal is to do a couple sections for next class, and then finish up chapter 11, finish up chapter 12, and there you go. Yeah, well, another one section here today. We'll take it as a little bit easy. Have this week to be a little bit of a breather week, so that's fine. Since there's no pie, there might as well do some learning. I'm sorry, there's no pie. But pie is delicious, okay? Like key lime pie, that's pretty good. Okay, a shepherd's pie, foot champ, pretty good. Okay, 100%. Chicken pot pie, absolutely outstanding. Pecan pie, very delicious. Apple pie, absolutely outstanding. Okay, cheesecake. Although that people consider that a cake, you can also consider that a pie in some ways. You know. Pie Face is live tomorrow to make up the missing stream tonight, so it's all good. Hey, it's okay. Listen, I just think about eating a nice actual food pie, right? Pie Face, I know you like going to Pie Face stream, so I respect that. You know when, actually, good question for you, Foot Champ. You know when, they're gonna release, respect, man, dude. You know when, they're gonna come out with, FIFA 22? And they're gonna start the new season for that. Then everything will reset, so you have an idea. Alright? Let's hear your idea. Around September 20th, give or take. Okay. Alright, very good. Very good. It's kind of ironic it's around that date, but hey. There you go. Birthday's on 3, so it's free. Very good. Cat, the only weapon against a math teacher is intermediate steps while making exercises. I think that's sadly mistaken, Cat. That is sadly mistaken. I think the only weapon against a math teacher is having them do any sort of exercise, period. That definitely applies to me. That's your weapon. Tell them to do some squats or push-ups. They'll definitely flop over like a fish. Hey, that's okay. Today may not be the easiest thing to do. We're talking about some testing here today, though not actually doing a test. We're doing hypothesis testing here today, so It's with sort of different things around statistics. So it may look a little confusing at first, but if you put the pieces together, it's not as bad as you may think. So you ever look at you ever look at a teacher and be like, man, that guy's just huge, just super big. Yeah, I have maths anymore in class. Yeah, I have a class anymore. What's bad to do with them? Hey, look, in 097, I had to do the same thing, okay? You know, I had to teach practical math for people who are doing welding and stuff. So, you know, it's still important. Still need the math at the end of the day. You know, still gotta do fractions and stuff. Now, don't put yourself down there, Foot. I think you're just fine. I was pretty bad at math for a while myself, alright? So, I think it just takes time for some people. For some people, it just takes time to kind of wrap their head around a concept. And you may not get it fully 100% completely, but, you know, if it takes you, a while, that's okay. Have ADHD and autism, okay. Like I said, one of the things about, thanks for the follow, Cat, I appreciate it. But that's fine if you have ADHD and autism. There are people who specialize in working with people who have ADHD and autism. That's perfectly fine. But the one thing that a lot of people preach, of course, is patience. All right. So patience is one of those things that is very important. You know, you have to be, even if you have ADHD or autism, sometimes you have to bring you back to focus or whatever the case may be. But still, at the end of the day, got to preach patience and be able to work it out on your own time, your own kind of little, your own little internal clock, and you go through it carefully, and you know, hopefully you'll be able to pick it up, and then you just repeat that process until it hopefully sticks. You know, and I put out the word hopefully because it's not a guarantee, but it's still at least they're trying, and the fact is that you're trying too. I don't fully get a lot of things either. Okay. Did welding and fabrication in college, and the practical was fun. The theory classes I never attended. You know, my class people around me, the wooden boxes around them, so they are fully closed off. My class, those people get those wooden boxes. Yeah, you know, I don't know. I don't know about those. Yeah, it prevents cheating. I know exactly what you're talking about there, Cat. But it's just like you just like sitting in a coffin doing a test. Oh Lord. Wah wah foot. That's a terrible pun, and I love it. I'll tell you, some people are really good with just doing the practical stuff. Like, but you may be one of those guys. If I put you in a job and I ask you, hey, could you do this? And I just showed you how to do it really quick, you could probably do it. It's just like you just need to be shown, and you don't need the book smarts to do it. You just kind of have that instinct, and you know how to do it. You try it a few times, you're like, all right, fine, I did it. And you did it well, you know, compared to the people who may have the book smarts to know how to do it. I've seen people succeed in those kind of environments as well. So I will make a point here to say, like, not everybody's made for academics necessarily. All right, that's actually a fair assessment. Some people are just like, I'm just not made for academics. But if you put them in a practical setting with their own two hands, yeah, they could be just as successful as the people who were in academics. It's just that kind of environment didn't work for them. You calling me dumb? My friend was like that, honestly. He was an army guy who moved to the Navy, and he didn't really get out of college. He tried college, it didn't work out for him. Tried it like 2 or 3 times. It just didn't work for him. Just not that kind of guy, but he's in IT and he makes like 60 grand, you know, and he can run circles around anybody else in the department without any trouble. So it's like all he needs is like the hands-on experience, and he knows exactly what he's doing. Like he could pick up a manual and be like, oh yeah, okay, I understand this, and then, you know, he doesn't really know the book smarts all that well. He's like, okay, I kind of get the gist, and he just kind of runs with it. Like, fine. He's just that kind of guy. Like, I respect that. I even told him, look, I'm like that. school's not for you. But if again, you're just a better practical worker than you are a book worker. 100%. In school, we had 3 chosen classes. Guess the 3 I chose. I don't know. There's a lot of classes I'm sure you could choose from. Why don't you tell me, what classes do you teach there? Public services, art, and my favorite, dance. Alright. Out of curiosity, what's public services? I get the last 2, but what would public services involve? Like, doing, like, community work? Toast service. Watching the meters. Okay, got it. Taking care of those scofflaws one at a time. Learning about public services, okay. Learning about, okay, so police, fire department, medical facilities, okay. All the hospital stuff. Gotcha, gotcha. There's actually more public services than people think. So, like, interesting, okay, hang on just a second here. We have Mazdy. Hello, Mazdy. How you doing today, my dude? I hope you're doing really, really well. Like, here's an interesting thing about public service. Straight up stressing? Why? Why, buddy? Why are we straight up stressing? Well said, Foot. Where can I sign up? Too much homework and a big-ass English paper due soon. Well, I know my homework isn't due anytime soon, Mazdy, so I don't think you have to worry about my end at the very least. Teacher was fit too? Alright. Okay. Fair enough. Your school doesn't believe in homework, luckily. Okay. So what do they do instead? Out of sheer curiosity. Well, yeah, you told me there's no homework, but there's got to be something as a substitute. Like, how do they make you practice on something or whatever? Or they just kind of leave you and say, hey, cat, just go out on your own, go do something. You know, go out in that field and go stand there for like 2 hours. I don't know, man. Go learn by staring at this patch of grass. Did dance showcases, drama performances, and people? Wow, that's really good, Foot. That's awesome. I'm really happy to hear that. What other classes in school? Okay, fair enough. Natty, hello. How we doing here? We got a CC. I danced my best grade. Very good. That's very good to hear, Foot. Really happy to hear that. I'm doing great. Absolutely fantastic. We're having a fun conversation here just to start things off with. You got an E in art, though? Well, that's okay. You know what? I would get an F in art, okay? So, I think you would do better than I would, my friend. Right? Art is not my forte, Foot. Definitely not. Definitely true. Look, Foot, I'm going to be honest with you. If you ask any math teacher who says, hey, could you do some art for me? You're going to not know a darn clue about what you want. They don't know how to do art, man. Like, science people, art is just, like, on the other end of the spectrum, man. Like, they have no clue what the heck they're doing. Art is just, like, way on the other side of the world. If it isn't a U, it's like an A for me. Alright. Well, raise your standards just a little bit. Give yourself a little more credit. You tried your best. Okay? And that's all anybody can ask for. You're not going to be perfect. I've failed math classes before, and yet here I am teaching mathematics. So, You don't have to worry. You don't have to worry about that. If you ever watch most of my streams here, Foot, my handwriting is atrociously terrible. Like, my handwriting's bad. When I started math, I was pretty bad at math. I'm not perfect whatsoever, you know. It really didn't start clicking for me until I hit like high school or something, where math started to get a bit easier. And even then, I still had a tough time learning how to study and put things together. By no means was my academic journey being perfect. And I don't think you need to put like perfection, terms on yourself. Just do your best and just work on improving little by little. Doesn't have to be by leaps and bounds. But hey, I think it's better if it's just like, okay, just a solid improvement. That's all. Yeah, it's kind of weird. Yeah, though let's not harm people. That'd be pretty bad. All right, I think we got most people in here, so I think we're ready to go. I'm gonna start a little late, but that's fine. I think I wanted to wait a little more time to people getting in the room here. I think if they didn't put you in a position to succeed, then yeah, I would agree that it would not be your fault. If you're not given like the proper material in which to actually do the actual exam, well then yeah, how would you even have a chance to pass? You're basically running off of nothing. So yeah, I would actually agree with you there. That's like giving like a quarter of the material for a whole test. I've seen that a lot of times, even in classes, classes like that. I've been in some of those tests where, oh, we never went over this material. Oh, but we're gonna give you an exam on it anyway. So how am I supposed to answer that? Well, you can't. So in any case, let's get going here with some new stuff. Gotta do some intros. Gotta do some stuff. I think it's a good idea. We get going. All right. Good beans. All right, let's do this, ladies and gentlemen. Let's do this. All right. Okay, let's get started today. Welcome back to Wednesday, end of the week time today. So today, ladies and gentlemen, today we are going to be moving forward here in Chapter 10. Is the last section in Chapter 10 here, which is going to be Section 10.4. We're going to be doing some more hypothesis testing here once again. All right. So hypothesis testing here, we've been looking at that so far. We've talked about it in a couple of concepts, whether it be proportions or again looking at the population mean. All right, so we looked at it in those two contexts. Now we have one more context that we need to look at in, and well, there's kind of like a fortunately or unfortunate part of this. Well, the fortunate part is that it's doable. The unfortunate part is, well, we're gonna have to do it the good old manual way. So yeah, this is gonna stink a little bit, but it's gonna have to be necessary here to get 10.4 out of the way, done and dusted. We're gonna have to do it the good old manual fashioned way. All right, let's take a look about how to do that, and let's see how that works. Okay, let's go to the big board here. See what we're working with. Okay. So we're going to go into our handout here from last time, and we're going to continue moving forward here with our handout. Here at question number 3. Yes, I'm Mr. Chibbs, Professor Chibbs. All right. So we're going to do number 3 here, and we're going to do something that we did talk about here back in chapter 9. All right. Good. Glad you're excited, my friend. All right, so back in chapter 9, we talked about the concept of a chi-square distribution. All right, so a chi-square distribution, we did that as a confidence interval from last time. And the only way we could do that last time is we had to find some critical values. We had to plug it into a formula. We found, the lower bound, upper bound, then did some other stuff with it. Found out what we got here at the end of the day. Bada bing, bada boom. Winner, winner, chicken dinner. Okay, now The only way we were able to do that, though, is of course doing it the manual way, where we had to use a table in the back of the book, and we kind of had to work with everything there in order for us to actually do that out. Once again, we're going to have to pretty much do the same thing here in this case. All right. And so we're going to talk about the steps on how to do hypothesis testing here using a chi-square distribution. Again, in this case here, the population standard deviation is going to be given here in a problem like this. All right. So let's look at question number one, or question one, step one. All right, step one here is we're going to determine the null and alternate hypotheses. Now, we've talked about this a lot here in this chapter. Again, the null and alternate hypotheses, again, the null being the base case here, alternate being the claim here. And what exactly are we going to compare this time around? In this case here, we're now going to be looking specifically at the population standard deviation. So now I'm going to compare the population standard deviation here in this instance from our study and from our baseline result. All right, once again here we have our three types of tests. We have the left tail test, the right tail test, and the two tail test. Okay, again we have to state our null and alternate hypothesis and state the type of test. Okay, now one of the things that I am going to stress here about this process, and the difference in this process compared to the other two processes, is really the type of test here is going to dictate, because we have to do this by hand, and I'm just going to set this out here. We have to do this by hand. So if we get to do this by hand, the type of test that we have here in step number 2, determining that type of test, is going to dictate everything else that pretty much happens after that point. And this is going to be incredibly important as we move forward. So let's stop here for just a second, okay? And I'm going to go through this process here, little bit by little bit here. In order for me to do that, of course, I'm going to go ahead and take a look at a particular problem. All right. Let's do a problem here together. We'll just go through it step by step here. We'll work with, again, just go slow. Go nice and simple pace here. I'm going to take off my face cam here. All right. Okay. So I would like you to look at number 10, which is a filling machine. All right. So let's take a look here at number 10, which says filling machine. Let's go ahead and read this off here. Then we'll need to set up the first two steps here. Again, the null and alternate hypothesis with the type of test. All right. Number 10, a machine fills bottles with 64 fluid ounces of a liquid. The quality control manager determines that the fill levels are normally distributed with the mean of 64 ounces and a standard deviation of 0.42 ounces. He has an engineer recalibrate the machine in an attempt to lower the standard deviation, so it's more precise. After the recalibration, the quality control manager randomly selects 19 bottles from the line and determines that the standard deviation is 0.38 ounces. Is there less variability in the filling machine? Is the 0.01 level of significance? Okay. Well, let's go ahead and at least set this up here first and foremost. Let's bring out our paint guy dude. Let's find our null and alternate hypotheses. So according to the problem here, what is going to be our null hypothesis for this problem? What's our null hypothesis for this problem? What is our population standard? What is our population standard deviation? What do we have here in this case? Type that in chat here. What is 0.38? Okay, so 0.38 was after the adjustment of the machine. What was it before we made the adjustment to the machine, Mazdi? Yeah, so this is like making that adjustment. There's 64. Well, 64 ounces here is what it should be, but that's talking about the mean here. We're talking about, okay, 0.42 is correct. So I want you to look at this carefully here on the screen. We are now talking about the context that we're looking over for a chi-square distribution is going to reflect the population standard deviation. All right, not the population mean. All right, not the sample mean, not the sample standard deviation. We're looking at the population standard deviation. So hence why we have this row here. So we have 0.42. That is going to be what the machine was before we made any changes to the machine. That's what was the population standard deviation was at that moment in time. I want to be sure everybody's on the same page here. Are there any questions about that part? I hope that's pretty clear about how I came up with that. All right. Does that make sense, Susan? I hope that makes sense there. That's okay. There's a lot that I would have to go over. Okay, cool. All right. Okay, let's look at the alternate hypothesis. So what is the alternate hypothesis here in this instance? So based on the wording that you see in the problem, what would the alternate hypothesis here be? Would it be less than? Would it be bigger than? Or would it be, say, not equal to? We have here for the alternate hypothesis. Okay, so Masty says less than. Okay, that's correct. The answer is definitely less than. Right. So we want to see if there's less variability. So we're going to have here. So again, the key word here, I don't want that number. We say, is there less variability? Meaning, is that less than 0.42? Remember, just as we talked about before, these two numbers should be exactly the same. We have 0.42 here. We're going to make a comparison to 0.42, which is our population standard deviation. Okay, so we got that going. Perfect. See, I know you could do a few things there, Foot. No problem. All right. Let's take a look at step 2. Step 2 is we have to determine the type of test. So, what type of test do we have? Well, there's only 3 possibilities. We have left, right, and two-tail. So which one of those 3 is it going to be? Is that going to be left, right, or two-tail? All right. That is correct. All right, so just looking at what we have here from our handout, we have a left tail test. All right. Now this is going to be incredibly important for what we're going to be doing here later, but we need to state this in step 2. Okay. Without a doubt, if you forget to actually label the test here, you're going to be in a whole world of trouble. All right. It's going to get bad, and it's going to get bad pretty quick. All right. You'll see why here in just a second. All right. So these first 2 guys, perfectly fine, set up and ready to go. Okay. Now we're going to get to step 3 and then step 4. Now step 3 is really easy because it's part that's given to you in the problem here. State the level of significance. Now the level of significance here in this problem is noticeably slightly a bit different. So that's given to us here at the very end is 0.01. So we're just going to state that here. It's given to us here in the problem. Just going to rewrite it down here because we're going to reference it. Okay. Okay. Now here's the difference here's where things are going to be noticeably different. And we need to go this next step here in a lot more detail. That is step number 4. Let's talk about this here as there's several moving parts to this part. So we're going to use 3 things here. We're going to use degrees of freedom, which was equal to n-1. We actually talked about that in the previous chapter. The level of significance, which we just stated. And the type of test, to find the critical value or values from table 7 in the back of the book. Okay, so we need three things here, okay? Let's talk about those three things. We need degrees of freedom, which is n minus 1. We need the level of significance, which we've already stated in step 3. And we need the type of test, which we stated in step 2. That'll help us find these critical values here that we need to find. The critical value that we need to find here. Okay, let's take a good look on how to do that. First and foremost, let's just go one piece at a time here. Degrees of freedom. Degrees of freedom here is equal to n minus 1. What is the sample size here in this case? How many bottles did we test according to the problem? Let's look at that. How many 64? We tested 64 bottles. Read it wrong. Okay. All right, 19. Okay, good. Woo. Scare me there. You scare me there, Natty. Also, one other thing, not every number in a problem is necessarily useful into solving that problem, by the way. Just to let you know. One of those little tricks about word problems that you have to keep aware of. It's not always true that every number in a word problem is necessarily going to fit with the process about how to solve for that particular problem. That's one of the mistakes a lot of people make. It's like, I have to make this number fit because there's a number in the word problem. And then I tell people, like, no, it doesn't have to work that way. I said if there's 3 quarts of like 5W30 oil and there's 7 quarts of 6W20 oil, whatever, how many quarts of oil do you have? Well, at the end of the day, it doesn't matter what type of oil that you got. You have 3 quarts and 6 quarts, you have 9 quarts of oil. So the type of oil doesn't matter. It's just the amount of oil that you got that matters. Same idea with this type of problem, though. Okay, so if we have 19 here, our degrees of freedom is going to be 19 minus 1, which is 18. So we're going to be looking at 18 degrees of freedom here, okay? And we're going to be having a level of significance of 0.01 and a left tail test. All right. Now we need to find that critical value. Now I need to show you how to find that critical value specifically. All right. So we're going to use table 7 here from the back of the book. All right. So let's use table 7 here from the back of the book. This is on page. This can be referenced from your electronic textbook. So pretty much have to use it unless they give you the table, because there's no way you'll find it on your own. There we go. This is on page A15. All right, we get to this this guy here. Now we did look at this here previously, but we're gonna want to make this a tad bit bigger here. Let's look at this carefully. All right. So notice here we have some values up top, and we have some degrees of freedom here on the left-hand side. Okay, actually, what is actually a good tip for this part here, and actually I'll make note about that here, if you look at the very bottom, the very bottom of this is actually very helpful here in this particular circumstance. Okay, all right. So I want to find this particular critical value. In order for us to find that here, first of all, reference the type of test that we have. So let's take a look back here really quick. The type of test that we have here is a left tail test. Okay, so I want to reference this bottom part right here. This says left tail. Now, what it says underneath left tail is very important. What it says here is it says that we're going to use the notation here of 1 minus this alpha here. Okay, so we're going to use 1 minus this alpha here in order to go ahead and find out what we have here for our guy. So you can also imagine here, by the way, another way to kind of visualize this is, you notice this kind of jumps from 0.9 to 0.1. Think about this right down the middle here would be kind of like everything over here. I guess I'll try and put it here. Everything over here is to the left, and everything over here is to the right. Okay, so this would be kind of the left, and this would be kind of the right, if you want to kind of imagine it that way. Another way to kind of visualize just based on what you see in the book and says, okay, I know that's left tail, I know that's right tail. In any case, let's take a look at here. The area is 1 minus alpha. Okay, according to this notation here, we're going to use 1 minus alpha. So let's go ahead and figure out what 1 minus alpha is based on what we have. All right, so 1 minus this alpha here, which is going to be the same guy that we have here. We have 1 minus 0.01. That's going to be 0.99. So it's like 100 minus 1. So, oh yeah, here we go. So this table is applicable to all of these problems. Yes, this is like the central crux to every single one of the problems. Yes, absolutely 100%. Like without this table, then there's no way I can make a comparison. So I'm really screwed if I don't have this table. So that's why I'm making like a big deal out of it. Is to say you got to actually look at this and carefully. You got to put the pieces together. That's the most important thing here in this process. Well, one of them anyway. There'll be one more important part, of course. Okay, so we have 0.99. We also have degrees of freedom here being 18. So let's take a look here on the table. We're going to look at the column here that says 0.99, and we're going to look at 18 degrees of freedom, which is right here. Let's take the row of 18 degrees of freedom and 0.99. So our critical value here is 7.015, according to the table that we have here. Okay. So we use the type of test, left tail test. We use the degrees of freedom 18, and we went ahead and because it was a left tail test, we did 1 minus that alpha. We got 0.99. We knew the column that we needed to look under and got the critical value here of 7.015. Before we move on here, are there any questions about that? Does everybody understand where we got that here? How'd we get 18? 18 we got here by taking the degrees of freedom. That's a formula here. We have n minus 1. So we did 19 minus 1 because 19 was how many bottles we checked. So that's how we got the 18. Cool. Any other questions? Okay. Let's go ahead and move forward then. So we can get this next part here. All right. So this next part here is just straight up calculation time. Nothing super fancy about that. That's good. Let's take a good look here at this next part. And we're going to do this here together. All right, so next we have to compute the test statistic. Okay, now here's the formula here for the test statistic. And it looks super fancy, okay? Now mind you though, it really isn't too hard to go ahead and fill in the blanks because that's basically all we're doing here. So here we got all this funky notation and that's all well and good. But basically at the end of the day we have some test stat here. This is basically like the test stat is equal to n minus 1 times s squared, n being the sample size, s being the sample standard deviation, divided by the population standard deviation quantity squared. Okay, that's basically what this is here. Again, um, if it helps, it may, I'm trying to think what might be helpful here. This might be helpful too, actually. Let me actually do it this way. Sometimes for some people, for whatever reason, I find it sometimes some people actually find this. Let's do that. Gosh, I wish this wasn't so tiny. One thing I really dislike about this program, it's just like, let's put these really tiny letters that you can't see. I'm like, really? That's so nice of you. I can't see crap. I'm super nearsighted. That is a squared. Yes, it is, Foot. Maybe this will make it a bit easier so you're not too confused. Yeah, trust me, it's awful. Don't worry, I'll be inserting this right there. All right, that makes it a tad bit better. It's pretty. Can you do it? I, I can't answer that question because I don't know either. I don't know why my program makes it that small. It makes it so super tiny. I'm like, why would you make this like so brutally terrible? It makes so bad. It is what American? I'm not sure about the question. You have to be a little bit more clear about what that means. We're in statistics here, so it's statistics, college statistics. Yes, yes, Foot. That's magnifying glass. Like, can't see crap. What the hell? All right, that'll make it a bit easier though, because again, you'll have the population standard deviation here, and you're going to square it. So if that makes it a bit easier to do, that's perfectly fine. And you can always replace this part here with test statistic. So if you want to just call this test stat, you could call this the test stat here. So I could just put this in parentheses next to it. I could just test stat. Okay. So I know you're British. I know. Just takes a little getting used to. That's all. Some things are said and done a bit differently. To be fair. All right. In any case, let's go ahead and take a look here at the test stat here, along with the given info that we have. So let's plug some stuff in, see what we get. Now, again, I'm not really going to use the notation here. You guys know me by now. I'm not a huge, super big notation kind of guy. Again, that's for your reference, just in case if you do see it for homework and whatnot, you know exactly what that's referring to. Okay. All right. So the test stat here, again, I'm just going to rewrite the formula here, and then we'll come back and do this in just a second. S squared. So n minus 1 here for s squared and this squared. Okay. Now, having said that, let's take a look here at the problem at hand. And this is back on page 5, somewhere around there. Lost the page there for a second. There we go. Okay, so we're going to fill in the blanks here, and then we're going to find this here using the calculator. All right. All right, so let's plug in. N here is going to be 19 minus 1. Can anybody tell me here, what is the sample standard deviation? What is the sample standard deviation? is the sample standard deviation? 0.38. Very good. That's right. All right, nicely done, Mazdi. That's right. So we took the 19 bottles there, right? And then the 19 bottles were tested, and somehow, some way, they came out to be 0.38 of an ounce. Fair enough. Remember, we're going to square that according to the problem. You guys type fast. I use the I use the side keyboard here, so I use the side, of course, the side one here. If you're on a laptop, then of course it's tougher to type out numbers if you don't have like the side keyboard there. So yeah, the number pad makes it significantly easier to type stuff out, no question. Oh, if you're using mobile, yeah, then it's easier on the mobile actually too. It's actually faster to type numbers on the mobile because the numbers are like up top and they're like super, like you can swipe over them. With like a laptop, it's harder. For whatever reason, laptops are some of the slowest keyboards ever. Like, for example, I don't know if I can shoot my keyboard. If I can, 2013. My keyboard here on the. Let me bring up my screen here for a second. So I don't know if this will get up to my. Okay, this is my keyboard here. I know it's upside down. But it has the number pad here on the side. So there you go. My RGB Corsair keyboard. That's pretty nice. Nice. Yeah, another swipe. Yeah. Give me my RGB keyboard. All right. All right. Okay, and we have the population standard deviation. We have the population standard deviation is what we found here, which is 0.42. Oh yeah, that's a good keyboard. I like that keyboard. So we have 0.42 here, and that quantity is going to be squared. Okay, so we're going to solve for this on our calculator here. Again, just be a little careful how we have to enter that in. But let's go ahead and put that in together here. Let's bust out our calculator. Oh wait, baby. Whenever you want. You're an adult. You can do it yourself. I'm not going to make you. It's totally up to you. You're an adult. So if you're an adult in this class, you could go whenever you want. Just not in the classroom. Go somewhere appropriate. Lord. That's fine by me. All right. So we got 19 minus 1 times 0.38 squared. No. 0.42 quantity squared. So this is equal to, now we're going to write this down here. This is 14.7347. Go out to 4 decimal places here. So this is what we have here. I don't need to know that. Hey, stop. Don't need to know this. DMI there. DMI. Okay, so let's take a look here at this. What we have here, we have 14.7347. Okay, so that's our test stat there. Pretty much a straight up calculation that we had talked about from before. However, one of the things that I've stressed here is that the type of test that we have is going to dictate. That's okay. That's okay. Just a little too much information. All right. Um, so, like I said, the type of test here is going to dictate exactly what's going to happen next. I'm going to use this test stat here also to help ourselves out. So let's take a look at the last step here as part of the process here to finally find the conclusion that we're looking for. However, again, I'll stress something very important. Step number 6, we're going to make a conclusion based on the type of test. So since we have to do this the manual way, we don't have a choice in the matter. If we're going to do a chi-squared hypothesis testing, you have to do it the manual way, then it does depend on the type of test that we need to be working with. That will determine if we are rejecting or accepting, whatever the case may be. Now, a left tail test, right tail test, and a two tail test have different types of comparisons. Let's take a look at them. A left tail test is if the test stat is less than the critical value, then we reject the null and accept the alternate. If it's a right tail test, if the test stat is bigger than the crit value, then the same thing applies. We reject the null, accept the alternate. In a two-tail test, you have to test two cases. That's if the test stat is less than the lower critical value, or the test stat is bigger than the higher critical value. You do find two critical values, by the way, in a two-tail test. Then, of course, the same thing applies. Reject the null and accept the alternate. Otherwise, it's going to be the other way around. Accept the null and reject the alternate. Okay. So since in this case here, we specifically have a left tail test. Okay, so we stated that here in step number 2. We said, hey, this is a left tail test. Okay, like I said, this dictates what we need to do next. So we have to answer the question here back in step 6. And let's go down here, step 5. So here in step 6, we just asked the question here, is the test stat. So the test stat here is, this case is 14.7347. That is our test stat here. Less than our critical value that we have here. And our critical value that we got here from the previous step was 7.015. So yes or no, is 14.7347 less than 7.015? Okay. So the answer indeed is no. Okay, right? Then obviously this is 14 is definitely not less than 7. So what can we conclude here in this case? What's our conclusion that we can make here if this is a no? Conclusion can we make here? Which one of these two conclusions that has to be true? You only get to have two answers, so use H0? Not sure what that means, Mazdi. I only care about two things here, Mazdi. Either reject the null and accept the alternate, or accept the null and reject the alternate. That's it. That's all I care about. Remember, we only get two possible final answers, so everything else doesn't matter. Except HO, okay. I can go with that. So here we have our final conclusion here. We can accept the null hypothesis and reject the alternate. Okay, good. That's correct. Very nice. Hey, Connor, how you doing, my friend? All right. Any questions about that? Everybody okay with that? All right. Get some rest there, Connor. Have a good night, okay? Who else is here? Anybody else? All right. Natty says Gucci. All right. Anybody else have any other questions? Everybody good? Susan, we okay? I haven't heard from you in a while, Susan, so I'm a little worried. Hopefully you'll be able to wrap your head around this a little bit. Okay. Like I haven't heard from you in a while. I'm like, uh-oh. Did the breaker switch in Susan's head just kind of flip? Be like, oh, bro. Those might have been the times that you hated me the first time you took my class. Not this one, of course, but still. You'd be like, you kind of look at me like, what the hell are you talking about? And why are you even talking? All right. I'll be like, yeah, all right. I can accept that. Never that. Though why always in the back? Why always in the back center of the classroom there, Susan? Like I could have sworn you were always in the back center of the classroom. Or in the back corner of the classroom. One of those two places, I believe. Like, like the further away I am from it, that means that the less they'll notice me. Hmm. Here's a hmm. Here's a mental note for you, if you wanted to know. Uh, we use a technique here when you teach. Is when you basically teach, you kind of think of an invisible line about 3/4 of the way through the room. You put it in an arc, and then you look through an arc there, and you just kind of scan the room like this, and then everybody in the room thinks that that you're looking at them. You know, like actually looking at them. I basically look at the back of the room, and I pretty much do the same thing. So watching every move, I pretty much do that because of the fact that I'm always looking at the back of the room and making a scan of the whole room anyway. But the back of the room is where I start, and then I get to the front eventually. So, welcome back. Like notice everybody's movements and stuff and body language. I start from the back of the room and work my way forward, and then basically I could just like absolutely wreck people. There you go. Um, okay. Let's go ahead and look at another problem here. Another example I think will do us a lot of good. So I'm surprised you remember. Hmm. Maybe the reason why I remember is because uh, the people in the back tend to have the more I don't know how to say it. The further to the front or the further to the back that you are, it's like it's a little bit easier for me to kind of connect you to. The people in the middle, I connect to in some regard, like for sure, I do connect to. But they more people for whatever reason, more people are open up to me who are sitting in the front or sitting in the back. Either that, or I get them to open up to me. So I know for most of the semester you stayed quiet, but I was like, well, the times you looked at me with like evil eyes, you're like, why are you talking to me and my face? Like, oh, okay. I understand. But for the most part, I figured we got along. So no. You ever have that? Okay, okay. Everybody knows about this face, right? It's that face that you get when you look at a person and you're just like, you know what? I'm just done with everything. And they're like, F you, F you, F you, F you, and especially whoever you are standing right there, just F you, and just like, I'm done. I am done. I'm done with whatever bullcrap that you're peddling. And I'm like, there's going to be days like that. No question. It doesn't matter how, how nice of a person you are. Doesn't matter how bad of a person you are. It's just like some of those days everybody's just kind of fed up because maybe something happening earlier in the day or whatever. Yeah, I'd run into some bad luck. Somebody said something you didn't like. Stuff like that happens all the time. So I was like, some people just gonna have those days. I see that face on literally everyone. So there's some days where you showed it to me, just like, mm-mm. Mostly when it's a rainy day. Sometimes for some people rainy day is great. Some people rainy day is like, I just don't wanna. Or maybe it's some days where it's my fault. Um, I remember way back when I had a student, right, as drinking Mountain Dew, right, and he was sitting next to this girl, right, and they kind of knew each other. So I'm like, okay, they're kind of flirting back and forth. So of course I decided to troll him just for the lulz. So I took his Mountain Dew and I just kind of looked at it. I looked at the Mountain Dew. Mountain Dew. I'm like, oh, that's pretty interesting. Said, getting a little, getting a little thirsty there, aren't you? Just in the middle of the class for no reason. It's just to absolutely wreck him. Just kind of swirl it around, put it down. Everybody laughed. It was so worth it. uh, I, he wasn't simping. No, no, no. The guy clearly was a player. All right, no question. It's just that the way I outed him was just like that. Because I'm like, if he's flirting around in the class, I'm like, I don't care if you flirt around the class. You can do it outside of class. That's cool. It's like I'm trying to teach some mathematics. Or if you're gonna flirt around in class, I'm gonna point that shit out and like, all right, let's do it. Okay, so um, unless they flirt with you, no, no, no. There's lines for that, my dude. That's a big no-no in teaching. That's a big no-no in teaching. Like having relations with students. Oh boy, I would get in a ton of trouble with that. You gotta do the do. No, gross. There's a difference, right? If it was a former student, then that's a different thing. You're two independent people. But if it's during a class, that's very inappropriate. So, and even then, you'd have to make that work, whatever. I really haven't been in that situation at all, so I don't guess I don't need to worry about that. I mean, if I had a girlfriend and stuff like that that went to college, okay. Anybody can go to college at any age, so that's perfectly fine. I mean, there have been people who've been in their 30s, 40s, 50s, 60s who went to college, so 20s, 30s, whatever, don't matter. That's a conflict of interest foot, so yeah. um, so the type of problem basically thing only in 10.4, yes. Let's go ahead and do another problem here. Let's go ahead and get into the problem here, Mazdi. Look, you asked the question, I answered honestly. All right. Okay. All right, here we go. So let's go to number 12. All right, so let's do number 12. All right, so number 12, let's go ahead and read this together here. And let's go ahead and see what we can do here. So you guys, for this one here, guys, I want you to guide me through this problem here about what you would do. All right, based on what you have in your notes. So I'm just going to go ahead and make up another one. We're just going to go through the steps here once again. So let's go ahead and read off number 12 so you can help me. Manufacturer of processed deli meats report that the standard deviation of the number of carbohydrates in its smoked turkey breast is half a gram per 2-ounce serving. A dietitian does not believe that the manufacturer and randomly selects 18 2-ounce servings of the smoked turkey breast and determines the number of carbohydrates per serving. The standard deviation of the number of carbs is computed to be 0.62 grams per serving. Is there sufficient evidence to indicate that the standard deviation is not half a gram per serving at the 0.05 level of significance? Okay, so let's go ahead and talk about these guys here. All right. What is our null hypothesis here? What's our null hypothesis here? You guys tell me. All right. Very good. Looking at our population standard deviation, we should have a half a gram. All right. Perfectly fine. See how you could write that too, Natty. That's fine. I mean, he's got the number pad. You could write 0.5 on your thing. That's fine. Type it out. It's fine. You can type it out too. It's not a competition who gets to get there first. I swear. I swear. I'm just asking everybody in general. I swear. It's no competition. It's not I'm the fastest number. Oh my gosh. You guys will be the death of me. All right. You guys are just fine. Okay. Let's take a look here at the next part. Alternate hypothesis. Not equals to. Okay, that's right. Okay, also true as well, Natty. That's correct. So again, as it says here, does this indicate that is there sufficient evidence to indicate that the standard deviation is not half a gram? So this doesn't say less than or bigger than, just says not half a gram. Okay. All right, and correctly stated here, it is two-tail. All right. Let's go ahead and put down our level of significance, which is half a gram, or not half a gram, sorry. 0.05 for our level of significance. I'm thinking half a gram in terms of the population standard deviation. That's not right. What am I doing? All right. Okay. Next. All right. So let's take a look at what we have to find next here. Next, we have to, let's go back to our guy here. Okay. First of all, before I go to the table here from the back of the book, what is our sample size here? What's our sample size here? How many samples did this person take here? Sorry about that. Yeah, 18. Sorry, I switched the page and I didn't mean to. I apologize about that. So she took 18 of those separate packages there. Now, let's take a look here, and we have a two-tailed test, and we have n is equal to 18 at a 0.05 level of significance. All right. Now, to showcase what we're going to be doing here in this problem, again, look at the very bottom of the page, right? The very bottom of the page is going to be your saving grace. As I mentioned here, this notation here is actually fairly helpful because it tells you what two columns you need to look under in order to find our two particular critical values that we're going to find here. Like I said, two critical values because we have a two-tail case. This is the only case that is going to have two critical values, by the way. But again, just want to stress that we will find two of them here in this instance. Okay, so first and foremost here, before we get to that, we can find our degrees of freedom here as 18 minus 1, which is 17. And then we go ahead and take our notation here. So let's do that first. We'll take alpha over 2, which is 5%, divided by 2. That's 0.025. We do 1 minus alpha over 2, or again, 1 minus 0.025. And so that's going to be 0.975. Okay. Okay. So let's find our critical values here. We're going to find a lower critical value. We'll find an upper critical value. So we'll find a lower crit value. Find our higher crit value. All right. Okay, so let's look at our table here. First and foremost, let's look at underneath 0.025. Here's 0.025, and we need to look underneath specifically 17 degrees of freedom. So here is 17 degrees of freedom. So we have 30.191. So let's go ahead and put that one down. 30.191. All righty. And let's take a look here also at 0.975. So 0.975 here is 7.564. Okay. So really quick here, are there any questions about how I went ahead and found those two critical values? Nope. Okay. Makes sense. All right. I wanted to at least do one two-tail case, so it's like, how do you find the two critical values? It makes more sense that way. Alrighty. All right, everybody good? Natty, you good? Yes. You need to find two of them because you have a two-tail scenario. So this is the only scenario we're going to find two critical values. If you have a left tail, that's going to be 1. If you have a right tail, that's going to be 1. But if you have a two-tail case, then you find two critical values. So that's why in the notes I put two critical values, because it can happen like in the two-tail case here. Last one we did was just finding the conclusion. I'm not sure what you mean by that question. What do you mean? If you could clarify what do you mean by that question there, Natty? I mean, we always have to come to conclusion. It doesn't matter. We're not done, by the way, with this problem. If that's what you're asking, I don't know if that's what you're asking here. Yeah, the problem we did before this one is the same type of problem we're doing now. So we're just at we're at step number 4 here. All right. We haven't gotten to step 5 or step 6, which is doing the test stat and whatnot. If that's what you're referring to, if I'm okay. Nah, that's okay. That's okay. I'm here to help. All right. Let's do our test stat here. That's the next part here. Let's go back to our problem, page 509. So we have n here, which is going to be 18 minus 1 times the sample standard deviation. What is the sample standard deviation here? What is the sample standard deviation? 0.0025? According to number 12? Number 12. Guys, number 12. Number 12. Oh my goodness, no! Whoops. Both are looking at number 11. Number 12. Although I will say this, you're not wrong. All right. Well, let's look at number 12. A half? No, not a half. It can't be a half. A half is what our population standard deviation is. Our sample standard deviation. Yeah, so this is from our sample here of our 18 18 2-ounce servings. So this has to be 0.62. Right? Remember, Standard deviation of the number of carbs was computed to be 0.62 of grams per serving. So that's what she got after she tested it out, right? That's why it's 0.62 here. And then we divide that by, now the half, I agree, is going to be down here. The half will be down here at the bottom, all right? So that part is true. We got half squared. Does anybody have an answer for me here? Anybody got an answer for me for this? What do we get for our test stat here? Twenty-six point 20. Okay, 26. Okay. Yeah, I was gonna say, I'm like, oh, which one is it? Okay, 26. All right. All right. Good stuff. Okay. All right. So that's step 5. Now let's do step 6. All right. So let's take a look here at step 6. We did all the tough parts here, all the way up to what we've done now. So now let's look at the type of test. We have a two-tailed test, right? That's what we have, a two-tailed test. So with the two-tailed test, we have to have two different comparisons. Either the test stat is less than the lower critical value, or the test stat is bigger than the higher critical value. So let's take a gander. We're going to ask two questions here. Is 26.1392 less than 7.564? And is 26.1392 bigger than 30.191? Again, if one of them is yes, if just one of them is a yes, then we can make our conclusion of rejecting the null and accepting the alternate. Okay. So let's go down the list here really fast. Oh, Mazdy's got an answer for me here already. Well, wait, no, opposite. Well, let's all right. Well, Mazdy like, let's put both answers down. I'm like, yeah, there's only two answers. So so is 26.1392 less than 7.564? The answer is definitely not, right? That's definitely not true. 26 is definitely not less than 7.6564. Is 26.1392, is that bigger than 30.191? Yes or no? No, right? So what's our conclusion then? What's our conclusion then? So Mazda, you put down both conclusions, but which one would it be definitively? Okay. What's our final result that we get here? Do we reject the null hypothesis and accept the do we reject the null hypothesis and accept the alternate, or do we accept the null hypothesis and reject the alternate? Which one is it? Okay, very good. That's correct. Yeah, so we're going to accept the null hypothesis and reject the alternate. Okay. right? So in this case here, that's what happened at the end. All right, yeah, so Natty, the answer is accept the null hypothesis and reject the alternate hypothesis. So remember here, Natty, only these two conclusions are the only things you can get, either this one or this one. The only two answers you're going to get here, all right? So one thing I don't want you to do is just kind of guess. Just make sure you check to see which category you fall underneath after doing that last comparison. Just please be a little bit careful about that so you don't just say, I'm not sure which answer this falls under. Go ahead and take a look at your notes there. Make sure you have the right comparisons, then proceed to go on from there. All right, any questions about that? Any questions? No? All right. Okay. Shoot. I got nothing to hydrate with. Hang on. Hang on, let me grab something. Because you redeemed a nice 300 points, so respect. Alrighty, good stuff. Nice. All right. Okay, so that will take care of it for today, ladies and gentlemen. I want to thank everybody for coming on out here to the stream once again. All right. I really appreciate it. Love you, all of you guys. You guys are wonderful. You guys are super patient with me as well, so I really appreciate it a lot. You guys are great. Let me switch to the main screen here. Okay, so the plan here for next week, just to let you know, is thank you. That's okay. Look, it's fine. We talk things out. We make sure we're all covered. You know, all our bases are covered. Okay, so that's important there. Great class. Fair enough. Thanks, Foot. Just to let you know here what's on the agenda here for next week. Next week we're going to go ahead and start chapter 11. Okay, so chapter 11 is going to where we're going to start off. We're going to hopefully get through a section or two about that. Again, we're heading into the home stretch here. So again, remember chapters 11 and 12 are the last two chapters here for the course. And once we're done with that, we're effectively done with the textbook. And we can go on and review here for the final exam, the last test in the final exam. So we're getting to that point there. We're not quite there just yet, so obviously not going to be talking about that here, but maybe in like a couple weeks time we'll be getting close to that point. So not you, them. You're fine. All right. Everybody all right with that, hopefully? Sounds good? Excellent. All right. Very good. All right. Cool. All right. We will see everybody here again next week. All right. Have yourself a wonderful weekend. And as always, everybody, stay safe, stay healthy, and most importantly, everybody, stay sane. All right, have yourself a great one, everybody. Take care of yourselves, and we will see you again next week. Love you too, mate. See you later, everybody. Bye.